Welcome to the Explainer. Have you ever really stopped to think about how computers talk to each other? Today, we are going to pull back the curtain on their secret language. We'll start with the simple little switch that made it all possible and go all the way to the invisible waves that beam the internet right to your devices. You know, it really does feel like magic, right? You tap your phone and boom, a video from the other side of the planet just starts playing. But here's the thing, it's not magic at all. It's actually this incredible journey that your data goes on, and we're going to follow that journey, every single step. And to really get it, we've got to go back to the very beginning. We're talking about the most basic language on Earth, a language that powers literally everything digital, from the watch on your wrist to the biggest supercomputers in the world. See, deep down, computers don't get words or pictures or anything like that. They only understand one thing, electricity. Is it on or is it off? That's it. So the big question is, how in the world do you build a complex language from something that simple? Well, the answer is this beautifully simple two-part language called binary code. Just think of a regular light switch. It's either on or it's off. That's all it can do. In the computer world, off becomes a 0 and on becomes a 1. And believe it or not, every single piece of information on your computer is just a really long string of those zeros and ones. But this digital language isn't just some abstract idea. It's physically real. Deep inside your phone's processor, there are billions of teeny tiny switches called transistors. And each one of them is acting just like that light switch we were talking about. When electricity passes through it, that's a 1. When the electricity stops, that's a 0. The whole digital universe is literally built on these microscopic, physical switches flipping on and off. Okay, so how do we get from a bunch of on-off switches to, sending complex thoughts, streaming a movie, or sharing your favorite emoji? Well, it all comes down to how we group those ones and zeros together. Let's start small. The tiniest piece of data you can have is called a bit. That's just a single 0 or a single 1. By itself, a bit can't tell you much. It's basically just a yes or a no. So what do? We group them. If you put 8 of those bits together, you get something called a byte. Now, with a byte, things get interesting. Suddenly, you have 256 different possible combinations of ones and zeros, and that's enough to represent every single letter of the alphabet, uppercase and lowercase, plus all the numbers and punctuation marks you need. For instance, there's a standard called ASCII. And in ASCII, the capital letter H is always represented by this exact byte, 0101000. So the word hello is just 5 of these 8-bit groups lined up in a row. See? It's just a code, like any other language. Now, ASCII was a fantastic start, but it had a big problem. It was pretty much just for English. And well, the world is a lot bigger than that. So a new standard was born called Unicode. Unicode uses more bits, which gives it enough power to represent characters from pretty much every language on the planet. And, yep, you guessed it, every single emoji you've ever used. All right, so we can now write anything we want in binary. But how does that message actually get out of your computer and into the rest of the world? The very first step happens inside your device, thanks to a piece of hardware called a network interface card, or NIC for short. The best way to think about a NIC is like it's your computer's mouth. It takes all that digital data, chops it up into these small, easy-to-manage chunks called packets, and gets them all packed up and ready to go. From there, those packets head over to your modem. Now, a modem is a really clever two-way translator. It takes the computer's digital language of ones and zeros and converts it into analog signals that can actually travel over physical wires. And then it does the exact opposite for any data coming in. It's the absolute critical bridge between your home and the giant world of the internet. But hold on a second. A lot of us aren't physically plugged into a modem with a wire anymore, right? So how does that message literally fly through the air? Well, this is where the everyday magic of Wi-Fi steps in. What your Wi-Fi router does is take those signals and turn them into radio waves. And these waves travel on different frequency bands. You can think of them as invisible highways in the air. The 2.4 gigahertz highway, for example, has a really long range, but it gets super crowded with older gadgets and even things like your microwave oven. Then you've got the 5 gigahertz highway, which is way faster with a lot less traffic, but its signal doesn't reach quite as far. And now there's the brand new 6 gigahertz highway, which is like a pristine, super fast expressway just for the newest, fastest devices. Okay, now imagine all of your devices trying to use these highways at the same time. It would be absolute chaos, right? A total digital traffic jam. So, to keep everything from grinding to a halt, every single device using Wi-Fi has to follow a super strict set of rules. Rule number one is all about being efficient. So instead of having just one big, wide lane, a really smart technology called OFDM splits that main data highway into hundreds of smaller, parallel lanes. This lets your router send a ton of data all at once without any of the different streams crashing into each other. It's pretty clever. The next rule, called QAM, is kind of like an advanced packing technique. Imagine you're trying to stuff a suitcase. QAM modifies the radio wave itself, changing its shape and size in really subtle ways to cram way more ones and zeros into every single transmission. The stronger and clearer your signal is, the more complex the packing can get, and the faster your internet feels. And on top of that, modern routers have a totally new way of managing all this traffic. See, the old routers could only talk to one device at a time. It was like having a slow, one-on-one conversation. But the new routers, they use a technology called multi-user MIMO. And that lets them have multiple high-speed conversations with different devices all at the same time. For a house full of gadgets, this is an absolute game changer. So when you put it all together, these data highways, the clever packing techniques, the new traffic management, all of these rules are constantly getting better. Engineers are always figuring out smarter ways to send more data more efficiently. And that is why your Wi-Fi just keeps getting faster year after year. And every new generation of Wi-Fi, the ones we now call Wi-Fi 5, Wi-Fi 6, and Wi-Fi 7, makes a really important improvement. Wi-Fi 5 was all about just getting more raw speed. Then Wi-Fi 6 came along to solve the traffic jam problem in homes with tons of smart devices. And the very latest, Wi-Fi 7, its main job is to slash lag, or what we call latency, making stuff like online gaming and video calls feel completely instant. And there you have it. We started with a simple on-off switch, and we ended up with a complex language of radio waves that has created a global network connecting all of us. This secret language is constantly evolving, which leaves us with a pretty fascinating question to think about for the future. If you found this breakdown helpful, be sure to subscribe to Refreshing Tech for more simple and useful tech insights. We'd love to have you. Thanks so much for watching.